Let's study 10th standard ICSE chemistry chapter 8 organic chemistry, the chemical properties of alkanes, alkenes and alkynes.
Let's start with the preparations of alkanes, alkenes and alkynes. I'm starting with this first. Later in the video, I will mention that it's not in the reduced syllabus because that was pertaining to the pandemic year, but usually it is in the syllabus every year. Now, methane and ethane. Lab preparation from sodium ethanoate, trivial name is sodium acetate. It's a salt formed from acetic acid. The H is replaced by sodium. If you react it with soda lime, that's a combination of caustic soda plus quicklime. Although quicklime doesn't participate in the reaction, it should be added because it reduces the deliquescent property of NaOH. So from here, COO, that is CO2, is removed and sodium carbonate salt is formed. And that's how we get methane. Notice that in the reactant, we had 2 carbon atoms in the raw material, but in the product, we have only 1 carbon atom. The same logic applies for the preparation of ethane. We have sodium propionate. IUPAC name is sodium propanoate. You need to learn both. Heat sign. And since carbon dioxide is removed from it, this reaction is called decarboxylation. And mark this as a GR. Now for all hydrocarbons, the collection will be done by downward displacement of water because they are insoluble in water, being non-polar covalent, and they are combustible, so we should not collect them over air. Now that was a lab preparation. What about the general method of preparation? So we take iodomethane, also called methyl iodide, and react it with nascent hydrogen, which will be produced by alcohol mixed with zinc copper couple. So this nascent hydrogen will attack it. One hydrogen will attach to the methyl to form methane, and the other hydrogen will steal away the iodine. So that's another way of preparing methane. Same logic applies for the preparation of ethane from ethyl bromide or ethyl iodide or anything like that. This third equation is cancelled. Physical properties are cancelled. Next, let's study the preparation of ethene, also called ethylene. So we start with alcohol, ethyl alcohol, ethanol. Now it's good to write it in the expanded form because it helps us to visualize what exactly is happening. Conc sulfuric acid is a dehydrating agent. So it will break this bond and create water out of it. So water is removed. So the carbon-carbon will develop a double bond. That's because carbon has 4 valencies and all 4 need to be satisfied. We can use alumina as well. Temperatures have to be learnt. This process is called dehydration because water is being removed. Another method is dehydrohalogenation. Here we'll start with bromoethane. So again, H and Br are removed by an alcoholic KOH. No, he's not a drunkard. When you boil it, H and Br are removed to form KBr plus water. And so the carbon-carbon develop a double bond. When your number of friends decrease, you need to have a stronger bond with the friends left. Now a general method, pyrolysis. You would have studied this in the chemical properties of alkanes. Here we convert a saturated hydrocarbon into unsaturated. We remove the hydrogen and make sure a double bond is produced between carbon-carbon. This is done in the presence of silica alumina catalyst at 500 degrees Celsius. It's also called catalytic cracking or dehydrogenation. Physical properties are cancelled. Now finally, preparation of ethane or acetylene. We start with calcium carbide. Just add water, no conditions, no catalyst, no temperature, no heating. The calcium is removed, so the triple bond remains, and that's our target. Just add hydrogen to them to get ethane. And what is left is calcium hydroxide, also called slake lime. This is cancelled. There may be some impurities like phosphine, H2S, which need to be removed. Another method, use alcoholic KOH and boil it with 1,2 dibromoethane. So H and Br will be removed from here, forcing the carbon-carbon to have a triple bond. That's how we get an ethane. And the products are KBr and H2O. This is similar to one preparation in ethene. And finally, the general method, cracking again. converting methane to ethane. We use 2 molecules of methane here. Electric arc producing 1500 degrees Celsius will get rid of all the hydrogen, or rather most of the hydrogen, and that's how we get ethane. Physical properties are cancelled.
Now we know that hydrocarbons may either be saturated or unsaturated. Saturated example are the alkanes, which have only carbon-carbon single bonds. And unsaturated hydrocarbons are alkenes and alkynes families. They may have carbon-carbon double bond or carbon-carbon triple bond. If there is a triple bond, that means only one bond is left, where hydrogen or some other element may be attached. Now, why do we call them saturated? Look at the diagram of methane or ethane here. If we wish to attach one more hydrogen anywhere, we can't, because the valency of carbon is satisfied with 4 different atoms. Each carbon atom is attached to 4 different atoms. On the other hand, if it is alkene or alkyne, we can add hydrogen further. It is not yet saturated. If we break this double bond into a single bond, if we delete one of the bonds, that means one valency is now available for each carbon atom, and we can then add hydrogen or chlorine or any other element out here. So basically ethene would now become ethane. Similarly in ethane, we can break 1 or 2 of the bonds and add more hydrogen to it. It still has the capacity to link with further atoms of hydrogen. Hence they are called unsaturated. This, on the other hand, is saturated. It has no more capacity for linking with more hydrogen atoms. So that's the give reason. Here there is non-availability of electrons. When we look at this bond is actually a shared pair of electrons. So here we don't have any electrons available for more bonds. Whereas here there is an availability of electrons to create more bonds. And that is why alkenes and alkynes are more reactive than alkanes. Always unsaturated organic compounds are more reactive than the saturated ones. Here, what kind of reaction can happen? Well, this hydrogen may get replaced with a chlorine, or maybe 2 hydrogen atoms or 3 of them may be replaced or substituted with chlorine. So typically substitution reactions happen for saturated hydrocarbons, whereas for unsaturated ones, addition reactions happen. Here we won't substitute the hydrogen, rather we can add a hydrogen or add a chlorine out here or anywhere. So we will be studying all these reactions now, but before that, please study the definition of substitution and addition reactions. Let's start with alkanes. So alkanes, definition, they are saturated, that means they have only carbon-carbon single bond. Aliphatic, that means they are straight chain. Hydrocarbons, that means they have only hydrogen and carbon. And their identity is carbon-carbon single bond, although we can't really call it a functional group. And since all 4 valencies of carbon are fully satisfied by forming single covalent bonds, hence we call it saturated. That's the good reason. They are also called paraffins, and they are comparatively less reactive, so almost inert. And the general formula is this. Sources is not important. Nomenclature, we've already studied that the first 4 names are same as common name: methane, ethane, propane, butane. Then IUPAC used the language, mathematical language, calling them pentane, hexane, heptane, etc. However, they may have some isomers, and then the naming will be different. This is how we draw the cross and dot structure. So you need to practice these cross and dot structures, and also the molecular formula, structural formula. Now let's study the preparations. Preparation is not there in reduced syllabus. So let's study the chemical properties. All the chemical equations have to be practiced and studied for the exam. As I said earlier, alkanes don't undergo addition reactions, they undergo substitution reactions. So if we have methane, that is we have 4 hydrogen atoms, what if we replace one of them with chlorine? Then we get monochloromethane. You can even say just chloromethane. And the common name, by the way, is methyl chloride. Such a reaction happens in diffused sunlight or UV light or when heated. 3 conditions, you can write any one condition. Why diffused sunlight? Because in direct sunlight it may be a little exothermic, highly exothermic, explosive reaction. This substitution reaction has a special name called chlorination. The definition: substitution of hydrogen atoms of compounds like methane by chlorine atoms. This may happen in alkanes, all alkanes by the way. So we replaced one hydrogen atom with chlorine. What if we replace one more hydrogen atom with chlorine? So we get dichloromethane. Can you guess how the structure would look? Yep, C, Cl, Cl and H. So that's CH2, Cl2. What if we replace 3 of them with chlorine? What if we replace all 4 of them with chlorine? So no hydrogen is left. So ultimately methane has become tetrachloromethane. By the way, trichloromethane has a special name called chloroform. Yeah, in the IUPAC name, no need to write 1,1,1 trichloromethane because there is only one carbon atom, so the numbering is not important since there will be no confusion even without it. Chloroform is a very profitable substance. It can be used to earn a ransom. You know the procedure, although it's illegal. Don't forget to write excess below chlorine in each of these reactions. So when it's not in excess, you'll just get monochloromethane. But if chlorine is in excess, then there will be more substitution to finally get the product tetrachloromethane. So a combination of all these 4 reactions, summary is this. So if we have a lot of chlorine, the final product we will get is directly tetrachloromethane. Let's do the same thing with ethane. Same conditions. And in excess, 2, 3, 4, 5, 6 hydrogen atoms may get replaced, and these are all the substitution products. And these products can be separated by fractional distillation due to the difference in boiling points. It's possible that after a reaction, you may get a mixture of these products. Say a lot of it is hexachloroethane, but there is still some tetrachloroethane or trichloroethane left. So how will you separate them? With fractional distillation. Now instead of chlorine, we would have used bromine. It would have been called bromination. Next, oxidation reactions. As the name suggests, it is a reaction with oxygen. Alkanes, alkenes, alkynes are good fuel. They burn with oxygen, give carbon dioxide, water vapor, and a lot of heat. In fact, alkanes are present in the natural gas, in your LPG cylinder, in the CNG cylinders. We have these hydrocarbons, which are a very good source of fuel as a fuel. So the reaction is, if oxygen is in excess, there is sufficient air, it will burn cleanly, just giving CO2 and water vapor, of course. Heat is also produced. If you wish, you can put an up arrow to show that it's water vapor. But in organic chemistry, that is not compulsory. If it is ethane, we also get the same things. Carbon dioxide and water vapor. That's it, nothing else. And it will burn with a blue, non-luminous flame. That is, it's not very bright, doesn't give much light, rather it gives a lot of heat. But what if there is a limited oxygen supply? Incomplete oxidation or combustion will take place, giving you carbon monoxide, which is quite poisonous. Or if there is very less oxygen, it will just give you carbon particles called soot. So it's always good to have a good supply of oxygen to these fuels. Next, chemical properties. We studied normal oxidation, which is also called combustion. Now let's study catalytic oxidation in the presence of a catalyst. So this is not burning, it is just catalytic oxidation, reaction with oxygen. So here, the catalyst is copper tube at 200 degrees Celsius, pressure is 100 atm. Alkanes are oxidized to form alcohols. Remember that. Alkanes form alcohols. Now these alcohols, on further catalytic oxidation, catalyst has to be written above the arrow, will give you aldehydes, plus water by the way. And this aldehyde on further oxidation gives you carboxylic acid. This is called methanol. This is called methanoic acid. Same is true for ethanol. Ethanol will give you ethanol, and ethanol will further give you ethanoic acid. Let's take another view of such reactions. What if we do a controlled slow oxidation in the presence of nascent oxygen being given by acidified potassium dichromate, which is an oxidizing agent? So remember, alkane becomes alcohol, alcohol becomes aldehyde plus water, aldehyde becomes carboxylic acid. Remember this. Always, alkane first on oxidation becomes alcohol. Alcohol on further oxidation becomes aldehyde plus water. Remember, plus water here, something unique. And the aldehyde on further oxidation becomes carboxylic acid. Now since we are starting with ethane, let's be specific about the names. Ethane becomes ethanol, ethanol becomes ethanol, ethanol becomes ethanoic acid. Of course, in exam, you can't write this equation. They will ask you something specific, like write a reaction in which ethane undergoes controlled slow oxidation, or ethanol undergoes controlled slow oxidation. So when you practice equations, please break it into 1, 2 and 3 reactions, and this also into 3 reactions, and write on 3 different lines. Notice that when you convert methanol to methanol, you have to write plus H2O. But the next reaction, methanol to methanoic acid, there is no H2O involved. That is already separate. Now, there is one more option. What if instead of copper tube, we would have used molybdenum oxide? No, it's not Mu, it's molybdenum oxide. 350 to 500 degrees Celsius temperatures. Different temperatures can be quite confusing. You need to remember this. What is special here is there is a jump. We know that usually alkane becomes alcohol. Even here, alkane became alcohol. But now here, alkane is jumping to an aldehyde and plus H2O, of course. So that is possible only in the presence of molybdenum. So how will these equations based questions be asked? Well, when you will go through the exercise and you will practice those questions, board questions and exercise questions, you will realize how are the questions framed. This is cancelled. You need to read the theory as well. Now, there is a special type of reaction called pyrolysis. This, you can think of it as a saturated hydrocarbon is becoming unsaturated. So how do we convert an alkane into an alkyne or an alkene into alkene? By pyrolysis. Some special conditions are required. For example, here I need 1500 degrees Celsius. And here I would require a catalyst like silica alumina, combination of silica and alumina, and 500 degrees Celsius. And in both the cases, obviously hydrogen is being released. Because what are we doing here? We are removing some of the hydrogen and we are converting the single bond into a double bond or a triple bond. If they have double or triple bond, they don't need so many hydrogen atoms, so that will be released. That's called pyrolysis. It is also called thermal or catalytic decomposition. It is also called catalytic cracking. It's a dehydrogenation reaction. D means removal. Since we are removing hydrogen, it is called dehydrogenation reaction. Later on, we will study the opposite. What if hydrogen is added? Then it is called hydrogenation. Uses have to be studied. Methane and ethane are used in the form of natural gas, even gobar gas. Gobar gas is formed from bullshit, cow dung, slurry, biogas. They have a very high calorific value, which means they give a lot of energy. So they're excellent fuels. They're quite clean as well. They only give CO2. It is also used in the manufacture of chloroform, carbon black, formaldehyde, methanol, and ethanol, which have various uses. So please study this. Next we come to alkenes. They are unsaturated because they have a carbon-carbon double bond. So there are at least 2 carbon atoms, which are not, the valencies of which are not fully satisfied by hydrogen atoms. Yeah, each carbon atom will have 4 bonds. So let's draw one more out here and here. But since it's double bond, there is scope for addition of more hydrogen atoms here. They are also called olefins. This is the general formula. We know how the nomenclature goes. And we also know that there are some position isomers depending on the position of the double bond. Notice that there is single bond also present, but if there is just a single double bond, carbon-carbon double bond, we call it an alkene. This is 1 butene and this is 2 butene because the position of the double bond is different. We can't have a 3 butene. Try it, because if you put the double bond out here, then we'll start numbering the carbon atoms from here. So this will become carbon number 1. Now, practice the cross and dot structure and the structural formula. Preparation is not there in our reduced syllabus. So let's go for the chemical properties. It's an unsaturated hydrocarbon. That means it won't undergo substitution reactions. It will undergo addition reactions. First of all, catalytic hydrogenation. As the name suggests, here we have addition of hydrogen. So if we have an unsaturated hydrocarbon, we want to make it saturated. Just add hydrogen. But that would require a catalyst like nickel, platinum or palladium. But we'll prefer nickel because it's cheaper. 300 degrees Celsius. Instead of writing it like this, even if you write CH3, it's okay. No problem. In chemical reactions, we don't have to draw the structural formula compulsory. If you draw it, it helps you to visualize and understand what's going on. So it's your choice. So this is the addition product. What if instead of hydrogen, we add a halogen, like chlorine? It's called halogenation. And yes, addition of chlorine would also require an inert solvent. You know, for this addition, it should be dissolved, but organic compounds don't dissolve in water. So we need an organic solvent, because like dissolves like. And that inert solvent, because we don't want it to react with these reactants, will be carbon tetrachloride. So what's happening here is the double bond is breaking into a single bond. See here. And one chlorine atom is getting attached here and the other one is getting attached here, because after all, each carbon should have 4 bonds. If the double bond is broken, that means one valency is pending to be satisfied, and chlorine will do the needful. And this is called 1,2 dichloroethane. So that's an addition reaction. Similarly, we can add bromine also to form 1,2 dibromoethane. Iodine, yep, same way, 1,2 diiodoethane. Notice here they have not written in the condensed form, they have written the molecular formula, which you can do while writing equations. Either you can draw the whole structure or you can just write the formula, your choice. I prefer structure because it helps me to visualize exactly what is being attached where, and to cross check that carbon has only 4 bonds. Sometimes accidentally we leave the molecular formula incomplete by having only 3 bonds or 5 bonds for a carbon atom. So avoid such silly mistakes. Now this reaction is special because bromine gas is brown in color. It has brown vapors. So if you pass it through a ethene solution, and when I say solution, not in water, okay, carbon tetrachloride. If I pass it through ethene solution, the bromine gas is being absorbed. In fact, it's getting reacted. So the brown color of the bromine will disappear. That's a chemical test to test unsaturation. The bromine gas is discharged. What does discharged means? The color disappears. So if I give you 2 beakers, one has solution of ethane and the other has a solution of ethene, how would you know which one is ethane and which one is ethene? Well, pass bromine vapors through both of them, and the one in which the brown color of bromine disappears has to be ethene, because if bromine color is disappearing means that compound was unsaturated. So that's a very important question which will come in exam, how to distinguish between a saturated compound and an unsaturated compound. By the way, even ethynes are unsaturated, so even they will give the same observation. We'll come to that shortly. Next, halogen acids. So if you have hydrochloric acid or hydrogen bromide, how will they react? Well, again, the double bond will be broken. Here H is attached, here Br is attached. This is called bromoethane, of course. Or you can even say 1 bromoethane, doesn't make a difference because it has to be 1 bromoethane. It cannot be 2 bromoethane. And this is called chloroethane. This equation is cancelled. What about sulfuric acid? Well, consider H2SO4 to be broken into H and HSO4. Now this reaction will happen only at 80 degrees Celsius in the pressure of 30 atmosphere. The double bond will be broken because these are addition reactions after all. The hydrogen will be attached here, the HSO4 will be attached here, and now this compound is called ethyl hydrogen sulfate. Why ethyl? 2 carbon atoms, so C2H5. Hydrogen sulfate or bisulfate, of course, that's HSO4. On the other hand, we can do the reverse reaction also. If we do hydrolysis of this, that is if we remove H2SO4 from it, we will get ethanol. This reaction is coming later on. So it's not exactly reverse of this, but it is hydrolysis. Here it is. We have ethyl hydrogen sulfate giving you ethanol, but you don't have alcohols in your reduced syllabus, so you need not worry about this. Next, yet another very important reaction, oxidation with the help of cold, dilute, alkaline potassium permanganate. Now remember, potassium permanganate, alkaline, is called Bayer's reagent. And like potassium dichromate, alkaline, even this is a very good oxidizing agent, which means it produces nascent oxygen. Along with water, they will react, they will break the double bond, OH will be attached here, OH will be attached here, and now we have ethane, 1,2 diol. You know, alcohol is all in all, but there are 2 ols, so it's diol. It's also called glycol. So this is another test for unsaturation. If I give you ethene and ethane, how will you distinguish? Well, add Bayer's reagent, which is purple in color, potassium permanganate alkaline. If it is unsaturated like ethene, the purple color will be discharged. It will disappear, and in its place you will have a green color. On the other hand, if there is no such color change, it is a saturated hydrocarbon or ethane. Next we have combustion. Combustion is straightforward. It always burns in oxygen to give you carbon dioxide, water vapor and heat. And a pale blue flame is seen. Polymerization. Well, these monomers or compounds, they attach to themselves to form a long chain, which can theoretically be having infinite number of blocks. That's called a polymer. So ethene plus ethene plus ethene plus ethene is polyethene. which is a plastic. Just like in biology, we have studied amino acids. Amino acids combine together to form proteins. Glucose molecules combine together to form carbohydrates. Similarly here, the double bond will be broken. So now one valence is left. That is why this hyphen is there here as well as here. It has to be shown. So this is one unit. Another unit will be attached to it. Another unit will be attached to it. And a combination, n number of molecules. There can be 10, 100,000, 10,000 number of such units forming a long chain. But such a reaction will happen only at high temperature and high pressure and in the presence of catalyst. This reaction is called polymerization. Then there are some uses of ethene. It's used in oxyethylene torch or oxyethene torch, which is similar to oxyhydrogen torch. It gives you very high temperatures of around 2800 to 3000 degrees Celsius, which is useful for welding purposes and cutting metals. You've studied in biology that ethene acts like a hormone. It can help in artificial ripening or quick ripening of fruits, and it's also useful in preservation of fruits. It is used for hydrogenation of oil. Oil is unsaturated. If we add hydrogen to it with the help of ethene, then it becomes hard and we call it saturated fats or ghee. So how is ghee made from oil? By hydrogenation. And some synthetic chemicals are also produced as well as some polymers. You need to learn all of them. Finally, alkynes. It is also unsaturated. It has a triple bond. Because of the availability of these electrons, it is quite reactive. This triple bond is called acetylenic linkage. Remember, each carbon atom should have only 4 bonds, 4 hyphens. And the series is called acetylene series. Nomenclature, we know how it's named. IUPAC names are important. We can have position isomers here. This cross and dot structure, you need to practice it, and even the structural formula. Lab preparation is no longer in our syllabus, in the reduced syllabus. Now the chemical properties. So there's a lot of similarity in these reactions and the ethene reactions. First of all, we have catalytic hydrogenation. So if we add hydrogen in the presence of nickel and 300 degrees Celsius, it will become ethene. So the triple bond has been broken, one bond has been broken and has become double bond. And if we add further hydrogen, which was done in the previous section, then we get a saturated hydrocarbon, ethene. When you practice this equation, you are not allowed to write it in one go. It's wrong. There are 2 equations, 1 and 2. Write it on 2 different lines. Because when you write the first equation, don't write the hydrogen out here. In the second equation, this hydrogen has to be written. Halogenation, again same logic. If one bond is broken, chlorine is added, so you get 1,2 dichloroethene. There's a double bond left, remember that. And the second reaction on the next line, this 1,2 dichloroethene in the presence of an inert solvent, when reacted with excess of chlorine, now you will get 1,1,2,2 tetrachloroethane. That's the addition product. These are all addition reactions, not substitution reactions. Same thing happens with bromine. So as I told you that since it is unsaturated, even this will give the test for unsaturation. Bromine vapors, brown color will be discharged, will disappear. Now instead of passing bromine vapors through it, another way we can test is take bromine water. Bromine water simply means bromine dissolved in water. And pass this gas through the bromine water. The bromine dissolved in water in the test tube was reddish brown in color. But when you pass any unsaturated gas like ethane or ethene through it, that brown color disappears. Something like this. So initially the bromine water is reddish brown. Even if you add alkanes, it's saturated, no color change happens. But if you add alkenes like ethene or ethane, then the brown color will disappear, proving that it is an unsaturated compound. With iodine, well, ethine can become ethene, that is a 1,2 diiodoethene, but further reaction won't happen. Next, halogen acids. Again, similar to the previous section, one bond is broken and H and Br are added. So that is called a bromoethene. Remember, ethene or ethane. Please write the next step in another line. If further HBr reacts, we get 1,1 dibromoethane. Same logic with HCl as well. 1,1 dichloroethane. Now you may wonder that here H and Br were attached. And next time, what if Br is attached here and H is attached here? Then bromine and this bromine are on different carbon atoms. That would have been called 1,2 dibromoethane. But we don't have such reactions in our syllabus because they will happen only in the presence of certain catalysts like peroxide. So you don't have to worry about it. Next, oxidation, Bayer's reagent, same as the previous section. Bayer's reagent is cold dilute alkaline potassium permanganate, which is a good oxidizing agent. It will oxidize the ethane to form ethane dioic acid. So notice here we have COOH, which is carboxylic acid group, and another carboxylic, we say dioic acid, and there are two carbon atoms, so we say ethane. So ethane dioic acid. So even here, the purple color of alkaline potassium permanganate turns into green, which proves that it was unsaturated. Combustion, well, same thing, it gives carbon dioxide and water vapor and heat is produced. If there is a deficiency of oxygen, of course, we won't get CO2, we'll get CO or just C. Now, we know that both ethene and ethane will give the same color change for test for unsaturation. Both of them are unsaturated. So how will we distinguish between ethene and ethane? Because both of them will discharge the brown color of bromine water. So now we have a special test, and this will help us to differentiate between alkenes and alkynes, both of which are unsaturated. Either you use ammoniacal cuprous chloride or you use ammoniacal silver chloride. This is cuprous chloride, not copper 2 chloride, which would be CuCl2. This is cuprous chloride, or you can say copper 1 chloride. Ammoniacal means it is dissolved in ammonium hydroxide. Even here, silver 1 nitrate is dissolved in ammonium hydroxide, so it's called ammoniacal. It will react with alkynes to give you a particular precipitate, along with other products, of course. And the color of this precipitate proves that it is an alkyne and not an alkene, because these reactions are not for alkenes. So that's how you can distinguish between, let's say, ethene and ethane. Copper acetylate has which color? A red PPT color. And silver acetylate has white PPT color. So that's a very useful test. And finally, uses, again, a lot of similarities. It is used in oxyacetylene torch for welding purposes, ripening of fruits, manufacturing some organic compounds, and some synthetic products.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.